algebra with formulas and measurement. Well, you do this all the time, but you may not have realized. But for example, just say, let's look at a rectangle, right? And just say this rectangle length is 4 and 6. If I asked you what the perimeter of this is, well, the perimeter, as we know, is like, well, it's length plus another length plus the width plus another width, right? So you could say that this perimeter is 2 times the length plus 2 times the width. Or you could say it is, well, the perimeter is, you could take a common factor here of 2, length plus width. Like these are all the same formulas, because if you go length plus width, there's 2 of those. You've got 2 lots of them. So you can substitute these into the equation, into any of them. So if you substitute into this one, it's going to form the perimeter equals 2 lots of the length. Let's go 6 plus 2 lots of 4, which would give you 12 plus 8 is 20. Or here you could go, well, the perimeter equals 2 lots of length plus width, which is 6 plus 4, which is 10. 2 lots of 10, which is going to be 20 units. So you use it all the time. Somewhere that you may not get it is, so that's one scenario. Another scenario could be, well, if the length of this is 6, and we know the perimeter is 20, what is the width? So you can use your formula to come back here and find it out. Well, you'll be like, well, obviously that has to be 6, that has to be 6. So that's going to be 12. You're left with 8, but you need to divide it by 2 because you've got 2 of them. So what you can do, and this is where you're using your substitution. Well, I know my perimeter is 20, and I know my length is 6. And this is how we use algebra to help us show what we're doing. So normally what you did is you go, well, I've got 20. We know that's the perimeter. We know the length is 12. And we have 2 widths. So you take away 12 from 20. So we minus 12 from both sides, which would show you that the 2 widths are left with 8. You've got to halve that because you just want to know what one of them is. So you divide both sides now by 2. So we can use algebra to help us solve equations. Alternatively, we could use the other formula. The perimeter equals 2 lots of L plus W. So we know the perimeter is 20 equals 2 lots of, we know it's 6 plus 2W, plus W. So we can now expand that. 12 plus 2W minus 12 from both sides. 8 equals 2W. Divide by 2 from both sides. W equals 4. So we can still see that we get to W equals 4. So that can help us. We could even use the same rectangle. You'll notice I'm using. Say, this is 4, this is 6. What's the area? Well, the area of that is going to be length times width. So the area of that is 24 square units. So you multiply them. But again, I could have taken away and said, hey, you know, the length is 6. We don't know what the width is, but the area equals 24 square units. What is the width? So the width of this, well, we know the area of a formula for a rectangle equals length by width. So we know the area is 24, and we know the length is 6 times the width. So you'd go, well, 6 divided by 24 would give you 4. So we can use the formulas to help us solve it, and we can use algebra to express this. So it should be equals. So that's where we work with it. So you can use this for a lot of things. So for example, if you've got a triangle, say it's 5, and the height of it is say 6, And what's the area of that? Well, the area is half base times height, if you recall. So we know that the area of the base is 5 equals half times 5 times 6. So the area for this is 15. Alternatively, again, and this is where formulas come into a bit more helpful in trying to solve it, we could say that, you have a base of 5. What's the height of this if the area equals 15 squared units? So, well, we can use the formula. So the area equals 15. Half times base is 5 times the height we don't know. Half times 5 is 2.5, but it's going to change into fractions. So what I might do is times by 2 on both sides. A half times 2 is just 1. So that's going to make it 30 equals 5h, because that's going to be 1 times 5h. Now I can divide by 5 on both sides. The height equals 6. So we can use this for many, many different situations. And that's really all we're doing in this next subchapter, is just looking at how we can find the areas of different shapes and trapeziums. Now it shows us different formulas. You can solve those in. So if you're given the area, if the area is something, you need to find out what some of the other values are. And we're just using a lot of the formulas to do that. So when we convert between Celsius and Fahrenheit, Fahrenheit's actually 1.8 times the Celsius plus 32 Celsius. So that will give you a Fahrenheit reading. So if it's 0 degrees Celsius, the Fahrenheit's 32. If it's 1 degree Celsius, it's 33.8. If it's 2, it's going to be 35.6. So, find C if F equals 95, you're going to substitute 95 in here, minus 32 from both sides, and then divide by 1.8. This one you might be using a calculator to help you guys solve, but it's more the process to how we get through that. So please have a go at some of these ones. So it's really about formulas and relationships and how we use it. We've got perimeter and length. We've got area as well. And that's where we're going with this. So you've used it a lot. You probably use it a lot intuitively when you're trying to solve questions with perimeters and areas. But you can use math to help us solve it, and algebra, and that's where it really comes into play. And it really helps a bit, well, it helps even more later when we're trying to solve a bit more technical questions. So for example, if I had an area of 6 was the area of this circle, area equals 6, and the radius just say equaled, what does the radius equal? Now, I know the area for a pi is pi r squared. So if I know it's 6 equals pi r squared, and this is probably going a bit more technical on, so it's going to be 6 on pi. You're going to divide by pi both sides, r squared. So r would equal the square root, and has to be positive to make it exist, on 6 pi. And that would be your exact answer. That's probably moving up to a level 9, level 10 sort of area there. But again, that's just showing you how you'd rearrange this and where we can go. That's a bit of extension there for you. Really at the moment though, you won't be dealing with squares and square roots. You'll just be dealing with other numbers that we've looked at with brackets on both sides, and also possibly brackets or variables on both sides. So have fun with that one. Yell out if you need a hand. Please have a go at the questions that are listed, and